is in this direction and its magnitude, so it's along the I hat. It's along the I hat, right? To the right, horizontally to the right. 15 Newton pushes a block weighting 5 Newton. What does it mean? The box weights 5 means هذه mg is equal to, يعني I can write it even like this, 5 Newton, of course, J hat. Oh, if I have to write this one as 15 I hat, then this is 5 Newton J hat, because he said it's 5 Newton and the weight is a force. The coefficient of static friction between the wall and the block. So here there is friction, huh? Here there is a friction. The coefficient of static is 0.6, so this is mu S. I have another one which is mu K. طبعا the reason he gives you both, he want to make sure you understand what you are doing. طبعا this is a very difficult question. In the unit vector notation, find the force in Newton on the block from the wall. On the block from the wall. And by default, I know that should be something here related to negative I hat. And I know by default. Why? Because should be something that has a negative I hat. Why? Because the wall will reply with a normal force against the block. So it should be something negative I hat. But that's not enough. There is also friction. Here there is a friction. So the wall also will have a friction force. يعني I have two forces. I had a difficulty question, but I decided to discuss it. So it has a negative I hat component because of the normal force, but also it has a friction force component because of the friction between the block and the wall. يعني, yeah, the wall has friction, so it applies force friction. When it will apply force of friction, we know something. ركز معايا. Force of friction will be silent and it's equal to 0 if there is no horizontal force. But what you have here, you have this force. This force will activate a friction force. صح? Why? Because it's against the surface. This force will activate the friction force. Yes. But wait a second. It's not enough. We need to decide if the block will slide or not slide, so that we know if we have to use a mu S or a mu K. So first we need to find a mu S maximum. And how to calculate a mu S Fs maximum? Mu S Fn. So let me show you. So we need first to calculate Fs maximum. Fs maximum mu S Fn. So the force, the normal force that the wall is imposing is 15. This one is 15. Minus 15 I have 15 because, friction forces, these are the laws are for magnitudes always. So 15 by mu S, the static coefficient constant, it's 9 Newton. Now we have to ask ourselves, the capability of a friction here, the capability is up to 9 Newton. But what you have here is what? Is 5 Newton. Means the weight is not enough to pull the object down. The weight of the block is not enough to slide it down. Means the block will be standing still. As a result, if this is 5 Newton, what should be the friction, the actual one? Plus 5 Newton J hat. Why? Because we determined the threshold. We found the threshold less than the horizontal force, which is in this case is the weight force, which means only the weight force, there will be a friction force to make it equilibrium because it did not exceed the threshold. So I have two components. I have negative I hat and I have 5J hat. And here is the answer. This is the correct answer. Yeah, difficult question. I want you to understand it. Try with it at home. I have other difficult questions. But you see, I hate sending you to the exam and say that there is something we did not take. I challenge you, I'll give you always things you've seen in a class. Always. But part important is not what I do. Part important is what you do. You have to solve it by hand. Make sure you understand it. Let's see here the chat. Here, chat. How did you get 15 I hat? I get minus 15 I hat. How? نرجع لها. Why minus 15 I hat? Because the block will have two forces. The block will have a normal force wall on the block, force from the wall on the block. If this is a plus 15, what this should be minus 15. But also I have a friction force because of the weight force. Okay. Another question. So this question similar in difficulty to the previous one. Here you have a surface. Here he tells you mu equals 0. Means هنا no friction. هذا no friction. أملس. Then you have something called a slab, and the mass of this slab is 50 kilogram. And you have a block on top of the slab, and the mass is 15 kilogram. So you have a slab, قطعة كبيرة, slab, 15 kilograms. And I have another mass called M2, which is called a block of 15 kilogram. طيب. Now what happens is the following. The question, just me explain it for you. Somebody is pulling on the block with this force. As a result, there is a friction between the slab. So he made it here, you know, like he tells you in the question even, there is a friction. As a result, if the block is moving to the left, this will slide the slab because of the friction, and here there is nothing. But because of the friction between the block and the slab, it might move the slab. Now, the question is how to find the force of a friction on the block. هذا البلوك. If this is the force of pulling, then the force of a friction should be in this direction. But remember something important. The force of a friction is between two objects, and it's opposite and equal. Opposite and equal, which means on the block, the force of a friction to the right, on the slab, the force of a friction to the left. Huh? Yes. That what will make the slab opportunity to move. And maybe you did this, I don't know if you worked, if you ever carried brick, marble, بلاط, بنسميه بالعربي بلاط. And it was stacked. يعني انت عندك هنا marble or brick, and I did work before in a brick factory myself when I was young. So if you have a brick, and the first rule, whoever teach you to do this job, he will tell you be careful when you take, say, one piece, this upper piece, be careful because this piece and this piece might move. Why? Because there is a friction here. Okay. So on the block, the force of friction to the right, on the slab, the force of friction to the left. Let me ask you, what are the forces on the block? All the forces. This force, the friction, the weight, and normal. These four. Okay? طيب. What is the force on the slab? Of course, I have the weight of the slab, and I have a normal force, and also what I have. I have one horizontal force, which is the force of a friction between the block and the slab. This one is the only one that will contribute to the movement of the slab. لأنه perpendicular ones will not contribute to the movement of the slab. Let's read now the question. I explained to you, but let's read it. A slab of mass 50, so this is a slab, the big one, rest on a frictionless surface. Yeah, here mu is equal to 0, frictionless. Floor. هذا الفلور is a frictionless. A block of mass 15, اللي هو القطعة الصغيرة فوق, rest on top of the slab. The coefficient of static friction is 0.6, and the coefficient of kinetic friction is 0.4. So you have 2. The 15 kilogram block is pulled leftward. هذه الفورس will pull the block. There is a friction on the block here. Okay? By a horizontal force of 100 Newton. هذه الفورس 100 Newton is known. Find the acceleration of the slab, not the block, the slab. Well, the only force affecting the slab that might, طبعا he said acceleration, he's telling you it's moving, so you have to use the kinetic friction. You don't, because he said it's moving, okay? So find the acceleration. None of these results are 0. So he said find the acceleration, which means there is movement happening. So I cannot use static. I have to use kinetic. So find the acceleration of the slab. We said, what are the forces on each one? On each one, first the block. The block has a force of pulling to the left, with force of friction Fk to the right. a slab has only one horizontal force اللي هي ال FK kinetic. طيب, so what is the law of Newton's second law? The force, total force on the slab, I'm talking about the slab, the question on the slab is equal MA, mass of the slab في A. Mass of the slab, so first of all I need to find mass of the slab is 50 طبعا, هذه ال 50 should be 50 here, but I need to find the FK. What is the FK? The FK is the same FK here, they're opposite and equal. So it's mu K M2G. Why? لأنه أبغى النورمال فورس للبلوك هذه النورمال فورس, which is M2 not M1, مش السلاب, it is the block. So I calculate FK, I multiply by the coefficient kinetic friction, I get 58.8. طب if I have FK 58.8 and I have the mass 50, I can find the acceleration. طبعا acceleration we need also to predict, is it going to be to the left or to the right? If the only force affecting the slab is to the left, where should be the acceleration? To the left. Why? Because Newton's law is very simple. F equals ma. So the force will take the same direction as the acceleration. And I have only one force, so I have only negative or to the left acceleration. I see hands raised, and I was waiting hand raised, and السؤال is not easy. Okay, Muhammad, Alma.
Doctor, the question is clear, but the thing is not why the friction forces to the left. That's low.
أنا هقول لك. شوف, الفورس of friction, remember we said between two objects, صح؟ يعني when you put a block on a floor, the force of friction between two objects, between the block and the floor. You agree with me? ركز معي, بدي اسمع إجابتك. You agree with me? محمد فين رحت؟ محمد يا محمد.
clear دكتور.
اوكي, ركز معايا. شوف يا محمد, when you put a block on the floor and you try to attempt to move the block, slide it, there is force of friction happens between the block and the floor, صح?
Yes.
We always worry about the force of friction on the block, but we never ask ourselves, what is the force of friction on the floor? The force of friction on the block is opposite to the attempted motion, but the force of friction on the floor itself is opposite to that one, to the upper one, to the one on the block, but it's equal. لأنه احتكاك بين سطحين, right?
Okay, so it's always just opposite.
It's always the case. It is always, يعني أنت you have, خليكم معي, هذا سؤال ممتاز يا محمد. هذا بلوك وهذه أرض, وأنا أدفع هنا بفورس F على البلوك. أقول لك where is direction force of friction on the block؟ تقول لي هذه. أقول لك where is direction of force of friction on the floor؟ تقول لي هذه. Equal and opposite. معايا؟
ايه دكتور.
Good question, بس أنا أبغاك تفهمها physically.
Thank you.
طب, another question. Anybody has his hand? Okay. حمزة برمندح.
So even if it was like we have three objects above each other, it will be the same case?
Yes, this is what happened. So and I have here, شوف, هذه أنا هنا object, وعنا عندي هنا another object, وهنا في احتكاك. شوف, هنا في احتكاك, right? Now, if I move this object to the left, the force of friction on this block at the bottom is here to the right. The force of friction on the floor here. طيب, if I now push with a force here on that upper block, the force of friction on the block, the upper block, to the left, but the force of friction on the lower block is to the right.
Oh, okay. Thank you.
يعني نبغى نغطي, we need to, cover it from all aspects. Why it's 28 over 50? It's not 28. That's a typo. I'm sorry. This is by the department. This is 58. Thank you very much. خطأ أنا. I should have told you. This is a typo. Please correct it. It's not 28.8. It's 58. It's the FK. It's a typo. They ask sometimes the secretary to type it, and the secretary is not a physicist or a mathematician, so he makes mistakes. Fine. We move forward. We have other questions. And I don't want to start chapter 7 before I make sure that you understand everything. So here we have another system. Here we have, let me just check the time because I need to control the time. In the figure 3 blocks, I have M1, M2, and M3. طبعا between M1 and M3, there is a wire, very thin wire. It doesn't have mass, okay, but it's connecting them. Now, there is a force applicable here to the right. Because of the wire, they will all move with the same acceleration. So he said, the force is 42, the mass M1, 1 kilogram, mass 2 is 2 kilogram, mass 3 kilogram. And horizontal force acts on this, which means this is the 3 kilogram, this is 1 kilogram, this is 2 kilogram, although they make it one is big and the other one is small. That's okay. But that doesn't mean anything. Sometimes it's a big block is made of wool or wood, and a small block made of iron, so it has more mass. Blocks M1 and M3 are connected with a light cord. What is the force exerted by M1 on M2? يبغى هذا الفورس الكونتاكت فورس. طيب احنا قلنا أول step I find the common acceleration. هذا الفورسز on this system is only this force اللي هي 42. So this 42 is the summation of all masses by the acceleration. I got the acceleration. So all the masses, they move to the right with 7 meters per second square. Positive, huh? To the right. ممتاز. Now, he wants this force. And I عارف إنه M2 also impose a force on M1, but he only wants the forces on M2, which means only he needs this. طبعا هنا يقول لك frictionless. لو كان في friction بدنا نضيف terms. هنا he said no friction. No friction. Between all the blocks and the floor, no friction. ريحني. So the only force is this one to the right on M2. So it is the force on M2, mass M2 بالاcceleration. The mass M2 is given 2 kilogram, multiplied by the acceleration. It is 14. Also, this question, by the way, is not defined as easy. It's challenging. It's medium level to difficult level. Tension 4 isn't equal to it. No, this tension force now is internal. Now this is internal force. I'm not worried about. Now, if I move the system, the only force that will move the system is this 42. Right. Good. Let's take, we have time for one more question on the incline. We have a car held in a place. What does it mean held in a place? Means held in a place معناها it doesn't move. معناها الاكسلريشن الهوريزونتال والفيرتيكال. طبعا هنا أنا عارف إنه ما في acceleration. هذا AY because the car is in contact with the surface. AY is 0. الآن AX is also equal to 0. ال AX هذه حظبطها. ال AX is also equal to 0. Why? Because he said it's held in a place. ما تتحرك السيارة. So what is the acceleration? Acceleration is 0. The cable, the mass of the car is given. The angle, there is a cable, so there is a tension force here. So this cable has an angle 31 degrees with the surface. طبعا الآن, remember something. This is now my x-axis. This is my y-axis. إذن هذه الفورس, the tension force needs analysis. So it is هذه الهوريزونتال T cosine 31 وهذه T sine 31. But we're not done. I have also mg on the car, its weight. And because of the angle of the incline هذه ل 25, it will be mg. قلنا هذه وش تكون؟ cosine 25. هذه للincline. And I have also more forces. I have a normal force. I need to analyze the horizontal component down, which is mg sine 25. هذه كل الفورسز. وش يقول كمان؟ Does he talk about frictionless? ما في friction. ممتاز. ما في friction. So don't have to worry about friction. He said, what is the normal force exerted on the car? وش قانون النورمال فورس؟ احنا قلنا النورمال فورس هذه النورمال فورس اللي هي هذه. But there is another force added to it, which is this one by the cable, which is T sine 31. So those two, I need to add them. So right here, so Fn plus T sine 31, okay, ركزوا معايا, minus هذه mg cosine 25, هذه اللي بتعمل equilibrium. mg cosine 25, هذه كلها وش تساوي؟ The right side total forces 0 because the acceleration on the y is 0. Now he wants a normal force, which means this one, but I don't know T. I don't know tension. ما أعطاني أي information about the tension. I need another equation, so I utilize the horizontal to find the tension. هذه equation الhorizontal. Only two forces. هذه T cosine 31 and I have mg cosine sine 25 اللي هي الويت component. Yeah. طبعا equal to zero الاكسلريشن. Equate them to each other. I got equation for the T. كل هذه الأرقام أعرفها. Now substitute هذه T هنا. You get a normal force. And that's end of the story. It's very easy. I hope everybody attempted to solve this question, but I want you also to understand it. نشوف إذا حدا عنده يد. Okay. Chat panel, just make sure. Negative. Yeah, minus mg. Of course, minus mg sine. Why? Because y minus mg minus mg cosine. So, but I know this. When I substituted the forces in the law, I put the negative sign, of course. Good. Anan Shamrani. Go ahead, Anan. Anan.
How do we know in the question that the acceleration equal to zero?
أنا عارف السيارة ملامسة للسطح معناها لا تطير ولا تحفر معناها الاي واي زيرو. You agree؟
Yeah, for the AY.
طيب والاي اكس والاكس شو قال لك بالسؤال؟ هيلد ان بليس. لما اقول لك حاجه هيلد ان بليس وش معناها؟ ما تتحرك. ما تتحرك الاكسلريشن زيرو.
Okay, thank you.
Good. This is good. طيب good. الآن so now we بسم الله الرحمن الرحيم again we'll start chapter 7. Chapter 7 we start a new era, a new part of this movie. I told you at the beginning this course is like a big movie. We started with measurement, chapter 2 motion in 1 dimension, chapter 3 vectors, chapter 4 motion in 2 and 3 dimensions with its applications, chapter 5 and 6 were about forces and friction forces. Now chapter 7 and 8 is about energy. And the first thing we should know is to ask ourselves a question. What is work or energy? Work بالعربي تعلمت الشغل, energy الطاقة. Both of these quantities are scalar quantities. What does it mean scalar quantities? It means they don't have direction. If they are positive means they're big. If they are zero means they're small. If they are negative, they're even smaller. Even scalar quantities, they don't have direction. They're just numbers. I add numbers to each other. Now, in order to discuss energy will work, energy الطاقة will work, both of them the same thing, we should know the unit of energy and work. The unit is called the joule. The joule is abbreviated by the letter J. So here is the abbreviation of the joule is the letter J. So this is the unit of energy. It's a scalar quantity, can be changed from one form to another. أعطيك مثال حب دائما أعلمه للطلاب. واحد معاه قطعة عجين, قطعة mud or clay or a dough. العجين تبعت البيتزا. يمسكها يرفعها عالي يلقيها على الأرض. وش يصير فيها؟ stuck. بس كان فيها طاقة. What happened to the طاقة? Suddenly it will die because the dough will stuck. Someone will say, oh تعال, إيه أنت بتقول في طاقة. كان فيها طاقة, لصقت بالأرض, it doesn't move. What happened? If you bring a thermometer and you measure its temperature, you will find it hot. All its energy, all its kinetic potential energy that it was there for that dough suddenly converted to heat. And that's why if even you touch the dough, you find it hotter than when you throw it. Very interesting. Another example, somebody brings a thermometer in a cup of water. هذا cup of water وحط thermometer يسجل مثلا 25 Celsius. He brings a spoon and he starts stirring the water. You will notice that the temperature will rise. Huh? Will rise? Yes. The movement of the spoon, the friction force between the spoon and the water molecule will be converted as heat, friction, and this heat will raise the temperature of the water. And that's one way to increase the temperature of anything, by stirring. Fine, good. These two examples that the energy can transform from one form to another, but it doesn't disappear. Yani if I have totally isolated system, I have a system that totally isolated, and energy went from one part to another part of the system, yeah, energy will not be lost because the whole system is isolated. So it can transfer from one form to another. Though energy, kinetic energy is converted as friction or heat. Yes, but it doesn't disappear. Right. That's a good introduction about energy and work. طيب, that's enthalpy. Enthalpy is another thing. It will be focus of chapter of physics 102. No, it's not enthalpy. It's enthalpy is one form of heat and energy, but that's not enthalpy. طيب. So kinetic energy, now we define something called kinetic energy. And kinetic energy اللي هي الطاقة الحركية, learned it in high school. It's defined as half mv square, which means if I have an object has a mass, two requirements. An object has a mass and he has speed or velocity, so he has kinetic energy. If the object is going faster, so the kinetic energy will be faster. If the mass is big, so the kinetic energy will be big. يعني the objects that they have massive kinetic energies, big kinetic energy, are the objects that are massive and speedy. If the object, the speed suddenly becomes zero, his kinetic energy becomes zero. The unit of the kinetic energy, it's energy. You see, whenever we mention energy or work, remember, the unit is joule. In physics, whenever we mention energy and joule, it is energy and work, the unit is joule. In chemistry, they have other units, but they are derived from the joule. For example, اللي هو الكالوري. In chemistry, when you learn something called calorie, الكالوري 4.18 of the joules. The basic unit is the joule. The unit that we love in physics is the joule. Why? Because it comes from half mv square. So this is m وهذه v square. It comes from kilogram meter second. So it is an essential unit. Why? Because it is derived from kilogram meter and second. So it is an essential and a standard unit. طيب. الآن let's derive the first law in this chapter. The law of this chapter, the main law of this chapter is called الwork. أنا أبغاك تركز معي, حبعد عن هذا السلايد اللي start here. شوف كيف. في قانون الشغل اللي هو الwork. قانون الشغل, it's a scalar quantity. So I will not put arrows here. It said F dot D. تقول لي اوه صارت غريبة شوي. لا مش غريبة ولا شيء. الفورس affecting an object by the displacement, هذه الإزاحة of the object, dot product. طبعا dot product is a necessity here. Why? Because I'm telling you this is a scalar quantity. When I know a dot product of two vectors will yield a scalar quantity, not a vector quantity. So work equals F dot D. So force is in Newton with D displacement in meter. So this is a Newton meter. So here is I have another unit of the joule. 1 joule is also equal in Newton meter. I derived another unit. طيب, هل هذا القانون الدوت برودكت, تذكر الدوت برودكت A dot B, we used also to write it in another format. We said magnitude of F, magnitude of D, and cosine angle between them, cosine theta. Where is theta? Theta is the angle between them. Let me give you an example. هذا object وعندي force هنا F. والobject as a result will slide to the right. معناها displacement, أين direction displacement؟ لليمين. As a result of this force. And this angle is theta. So كيف يصير القانون؟ الwork done by the force F is equal magnitude F, طلع magnitude of that force, magnitude of the D, cosine theta. وحقول حاجة هنا مهمة وأرجوكم انتبهوا كويس. أنا عارف بعض الناس تدرس هذا الشابتر بطريقة مختلفة. But from my experience, my humble experience of teaching this course 20 times, 20 مرة, I can tell you the following. The method I will teach you is the easiest one and you cannot make mistake. أنا عارف بعض الجالسين الآن حضروا videos or they attended some lectures online. He said the component of the force. أنا ما أبغاك تدخل بها التفاصيل. أين الفورس؟ أين الدisplacement? And where is the angle between them? Let me give you another example. Here, if there is this force, what is the work done by the friction force? هذه الفريكشن force, right? طب where is the displacement? احنا قلنا displacement لليمين إزاحة. So what is the angle between the force of a friction and the displacement? 180. That's why the force of a friction, cosine ال 180 negative 1. So the force of a friction will do a negative work. نعطيك مثال آخر. Here. نعطيك مثال آخر. هذه الماس وهذه الويت، صح؟ هذه الويت mg وهذه الديسبليسمنت وهذه النورمال فورس. By the way, what's the angle between displacement والnormal أو between the weight and displacement? 90. And normal force والweight force they do zero work. Why? Because cosine 90 اللي هو القانون العام F dot D يعني magnitude F magnitude D cosine 90 is equal to zero. That's why normal force والweight force they do zero work. طيب شوف الأسئلة هنا أو بالشات. Yes, 0, 90, perfect. Energy can neither be created, destroyed, only converted. Yes, this is a common law of energy. Yes, common law of energy. This is good. Somebody's doing good reading. Have to change my device. It's okay, no problem. I'll wait you. Right. So here, this law, he derived it from the law I showed you, F dot D. He derived it from one of the equations of motion. Multiply all sides by half m. هذه half m, هذه half m, هذه half m. You get this. معناها الwork is equal F dot D. لكن هنا I want you to read this carefully. This is what your friend wrote somehow. Work is energy transferred to or from an object by means of a force. Energy transferred to the object is a positive work. Energy transferred from the object is negative work. Now you know something. The work done by the friction force is negative because of the angle 180. But it means that the friction force is taking from the energy of the object. The force that I show you with an angle cosine theta making positive work because cosine less than 90, which means this force will add to the energy of the object. If an energy transferred to the object is positive work, energy transferred from the object like friction, like the work done by friction, is negative work. Okay, good. ممتاز. This is the law I talked to you about. الwork is F, magnitude F, magnitude D, cosine angle between them, or F dot D. هذا القانون I can use it in another format. Imagine the force is given as I hat and J hat. Yeah, you do dot product directly without knowing the angle. يعني لو أقول لك الforce of friction 2I hat and 4J hat with displacement is 3I hat. What you do? Dot product. Just do the dot product. So those two forms are equally important. This one, if I need to know the angle, and this one, if it's I hat, J hat, K hat, I just do the dot product between two vectors. I hat, J hat, K hat, I hat, J hat, K hat. And what I will get in both cases, I will get a scalar quantity. So to calculate the work, the force, the work a force does on an object as an object moves through the some displacement, we use only the force component, okay? The force perpendicular making zero. يعني is another format of what I said, cosine the angle. That's why the weight when normal force they do zero work. أبغاك تفهمها ما تحفظ شيء. Now, for two or more forces, the net work is the sum of the work done by all individual forces. أنا أعطيك مثال على هذا الستيتمنت. Imagine now I have a block وفي واحد هنا يدفع بهذا الفورس. طبعا الديسبليسمنت لليمين. So this force will do positive work. طبعا أنا عندي هنا الويت force. Here I have a normal force. And I here have the friction force. If I said, find the works done by all the forces, you just add numbers. You find this work, F dot D, which is positive. You find this work, which is a negative value because of the angle 180 between the displacement and the friction. And those two will do zero work. So basically the net work is this positive minus this negative. And that's the net work. So the net work is the number sum. It is a scalar quantity, is the number sum of all the work done by all individual forces. So here I give you two methods, or I show you two methods. The first method, if you ask about the total work, you find a total work by finding the individual works for each, like this example. I found the individual work for this one, an individual work for this one, individual, and then add them. So this is the net work. But there is another way. The other way is instead of I find the net work by finding each individual work, I find the net force يعني القوة اللي هي resultant force due to these four forces, and the resultant force due to these four forces is what? This one, those two will cancel out. A normal force will gravity. So here, this force minus the friction. الطرح بينهم is the net force. I find the F net, and then I multiply by the net displacement. يعني, let me explain it here. The work total, the first method is what? Work 1 plus work 2. I find the individual works plus work 3, all the forces affecting the object, plus work 4. Another method, الwork total هو F net, النت force dot النت displacement. هذه لك الحق تستخدم هذه الطريقة or this method. طيب, let me see questions. So it is like gaining and losing, then multiplying by D. Yeah, net force. In net force, the way I find the net force, I find the net force. If they're two opposite forces, I have to subtract. If two same parallel forces, I have to add them. Two perpendicular, I have to find the resultant. يعني لو عندي force هنا و force هنا, النت I have to find it from the resultant اللي هو Pythagoras law, square root. Okay? So by both methods should yield the same results. Then both methods should give me the same results. Good. طيب, الآن we come to a topic, section 2 of the chapter, called the work kinetic energy theorem. The work kinetic energy theorem is a very important theorem. They will ask you in the exam. شوف الchallenge, there will be a question in the exam for sure, midterm. The theorem is very simple. The writing of the theorem means a change in kinetic energy of an object equals the net work done on the object. هذه بالwriting. يعني if I find the change in kinetic energy of the object before and after, then it's equal to the net work done on the object. يعني لو كان object يمشي بسرعة معينة و his velocity changed, listen, object is moving with certain velocity. His velocity changed. It should be there is a force that they did work. So in net, variation in his kinetic energy is equal to the work done on the object. طيب, كيف نكتبها mathematically? A change in kinetic energy is K final minus K initial equals the work net. Okay, let's take an example here. Kinetic energy of a particle is initially 5 joules. So I have a particle moving, has certain mass, has certain velocity. So his initial kinetic energy is 5 joules. A net transfer of 2 joule to the particle, which happen means a net هذه is 2 joule. A net work on the object. معناها ال K final what it should be? 7 joule. So 7 minus 5 equal to 2. Again, another example, if the particle initially 5 joule, and if a net transfer from the particle means negative 2 joule, yeah, if it's negative 2 joule, well, this one is 5, this one has to be what? 3. So the kinetic energy final should be 3. يعني this is the work kinetic, but remember, this one is important. Change in kinetic energy of an object equals to the net work done on the object. مش by the object, on the object. يعني change of kinetic energy of the object equals to the net work done on the object, not by the object, on the object. It's important that you learn it. طيب, we have examples طبعا. Let's take this example. A particle moves along the x-axis. Does the kinetic energy of the particle increase, decrease, or remain the same if the particle velocity changes from -3 to -2? Oh, a particle moves along the x-axis. Does the kinetic energy increase, decrease, remain the same if the velocity كانت initially -3 becomes -2? معناها الانيشال v square وهذا v square half mv square. طبعا الماينس is not important in kinetic energy. Why? Because I have only to worry about the square of the speed. Why? Because it's half m v square. So what's important is the v square. It's not important if it's negative velocity or positive velocity. I have to square it anyway. So if it was minus 3 and becomes minus 2, كأنه أتكلم على 4 minus 9, the energy will decrease because the change in kinetic energy is negative. If it was minus 2, means 4 units, and square then became 2, which is another 4, the energy remains the same. Kinetic energy change is equal to 0. In part C, in each situation is the work done on the particle positive, negative, or 0. In the first situation, the work is negative. Why? Because the change in kinetic energy is negative. In the second case, اللي هو part B, the net work is equal to 0. It's not positive or negative. Straightforward. ما فيها صعوبة. Let's take this example and then inshallah we can finish. Here you have two spies, يعني two thieves or spies. They try to move the safe to the right. هذه displacement. إذن هي net movement. They try, يعني both of them, they try to move it to the right. Means this is the direction of the displacement I needed. Shows two industrial spies sliding an initially stationary 225 kilogram safe. طبعا a displacement of the magnitude 8.5. So they move it to the right by 8.5 meter. معناها the vector of the displacement is 8.5 I hat positive. Now I know the displacement vector. Why? Because he said it's moving it to the right along the I hat, because it's a vector quantity displacement, 8.5 units, 8.5 meters. طيب. Okay, طيب. The push F1 spy 1 هذا البنت, she push with a force 12 Newton directed at an angle 30 degrees downward. كأنه الفورس هذه حق البنت تعمل 30 degrees مع السطح هنا. يعني كأنها تدفع للأسفل ب 30 degrees. طبعا الفاليو is 12 Newton. Its force magnitude 12 Newton. The direction 30 degrees with the horizontal and with the displacement. The second spy, he is moving it with a force, but that force is making an angle like this. He's pulling up as if he's pulling up. So he's making an angle what? 40 with the floor, with the displacement. طبعا هذه الangles both with the displacement مهمة جدا. البنت تعمل 30 degrees with the displacement. الولد يعمل spy number 2 اللي هو 40 degrees with the displacement. طيب. What is the network done on the safe by forces F1 and F2? Only بسألك بقول لك جاوبني فقط النت work, not by all the forces because I have weight, I have normal, I might have friction. No, he said only by F1 and F2. النتورك. طيب. المethod we said either we find the individual works then we add them, or we find the net force and then we find the net work. أول حاجة الفيرست work due to the البنت هذه الفورس حقها 12 الدي magnitude هذه magnitude 8.5. What is the angle between a displacement and the force of the بنت cosine 30. حل كم طلع 88.33. خلصنا. في أسهل من كده؟ ما في أسهل. What is the work done by the man? A displacement like this horizontal will angle 40. So magnitude of the force by the spy number 2 is 10. A displacement magnitude 8.5, cosine 40, 65. In net work, you add them, numbers. You add numbers. Work is a scalar quantity. This is one method. Part B, he said, during the displacement, what is the work done on the safe by gravity? Gravity? Where is the force of gravity? Down. What's the angle by the displacement and force of gravity? 90. What's cosine 90? 0. What is the work done by the normal force? Also 0. Why? Because the angle between the displacement and the normal force is 90. Cosine 90 is 0. The safe is initially stationary. What initially stationary means? The kinetic energy initial equal to 0. طيب. What is the speed V final? خلاص أنا عندي القانون الwork net equals the change in kinetic energy. So الwork net إحنا حسبناها هذه 153 net work. K initial is equal to what? 0. معناها هذه أسويها تصير half mv square. معناها هذا الترم is equal to 0. والماس I know it. Take a square root تطلع معاك الفاينل speed of the safe. الفاينل speed of the safe. أنا حضيف حاجة على السؤال. هسألكم عنها. Now, if the two spies displacement was up هنا هذه صارت الديسبليسمنت يا رفعوها رفع على يبغوا يرفعوها للطابق الثاني. الديسبليسمنت is up what will be now الwork؟ شوف هذا، هذه الفورس ما تغيرت 40 مع السطح هذا، معناها الانجل مع الديسبيسمنت كام؟ 50. You agree with me؟ كوساين ال 50 والبنت هذه الانجل كم؟ 30 مع الديسبيسمنت كم؟ 30 بلس 90 معناها كيف؟ كوساين ال 1 20. يا سلام. الان اللي حسأله السؤال المهم، هذا مش مهم، على الشات بانل what is the work done by gravity؟ جاوب على الشات بانل. where is the force of gravity؟ تحت. والديسبيسمنت up. الانجل between them is what؟ is negative. cosine ال 180 negative. طب what is the work done؟ Thank you. Most of you answered. What is the work done by the normal force؟ الديسبيسمنت up والnormal force is up. cosine الزيرو is positive. يا سلام لو تفهم لي هذا المثال. لو تفهم لي هذا المثال حتكون ملك رائع. طيب now let's add another force. There is another one applying this force. وهذه الديسبيسمنت لليمين. Where is الانجل؟ هذه الانجل بينهم. إذا أعرف الانجل between I can find the work 3. And I can even add it to the other force. If he said now 3 spies applying force. Please think about this example. It's a very interesting example. We have to stop here, ya shabab. We're out of time. Inshallah, we continue next time. Anybody has a question? No one? So inshallah, we continue next time.